All right, so we're starting solving quadratic equations by completing a square. I'm going to go over some of this stuff again. I got to record this for some people. So what does it mean to have, like, what are we looking for if we're looking for the solutions to a quadratic equation? X values, more specifically, the roots, and where are they found if you're looking at a graph? The x-intercepts. And the real reason for that is because we can write, we can write f of x equals ax squared plus bx plus c. And so when we set it up, I've told you that it's 0 equals all of this stuff. And so what you're saying when you do that is, give me the x values, or rather, I want to find the x values when y is 0. And that's why they ended up being on the x-axis. Okay? So right now, you kind of mentioned one, but we have two ways that we can solve these. What's one of them? Factoring, right? And we, what's happening right now? Grace, you're doing what? You're doing, okay. So I'm going to get her going here in a second. But, yeah, factoring is one, right? You get set equal to 0. Factor, set those factors equal to 0, and then solve. Why don't we do that all the time? Not everything can factor. So then what can we do? All right, so somebody said it, here, listen. Somebody said it, the other option is to graph. And so then you graph them and look for where they cross the x-axis. Why don't we do that all the time? It's not very accurate, right? And so we want to be accurate. Sometimes accuracy matters, okay? So we're going to start this today. It's called completing the square. It's a whole method. We're actually not doing the whole method today. We're going to start that tomorrow. So as of right now, it's like you're doing the last couple steps. Okay, so we are supposed to always set it equal to 0, but they've already moved off of that a little bit. So you just have to accept that that's still really the first step. We're not doing it today, okay? So they got some things in here. Some of the terms, completing the square, that's the method we're using. Vertex form is what we're going to start on Thursday. It involves completing the square. And then projectile motion problems, that's like the big famous thing that you can do with quadratics. Throw something up and it comes back down. How long does that take? Shoot a rocket over there, it comes back down. Okay, how long does that take? Okay, so important stuff. Trying to go to the moon, I hope I hit it. Right, this is all this kind of stuff. So the first thing that we need to understand is the square root property. Now it's pretty easy. And I'm going to use this example up here. The x squared minus 49 equals 0. Now in the last section, you were asked to factor that and set it equal to 0 and things like that. But if you watch the video, I was like, I wouldn't do that because it's very easy to do it like what we're doing here. And so what you would do is say, okay, so x squared minus 49 equals 0. I'm going to add 49 to the other side. And then I'm going to take the square root. So then I'm going to square root both of these sides. The square root property says that if you're doing the square rooting, you better get a positive and a negative answer. So this would be x equals plus or minus the square root of 49, which of course is plus or minus 7. So you're getting two answers out of this. And there's a couple things that tell you that. The first thing is that this equation has a squared term. That's how many solutions you should be looking for. If it was a cube, you'd be looking for 3 of them. Okay? The other thing is that an answer to an equation is what you plug in that makes it true. Okay? So if you're thinking of something squared, for instance, squaring 7, you would get positive 49. But if you also squared negative 7, you would get positive 49 again. So therefore, they're both answers. So the thing that you got to remember to do is every time you take a square root in an equation, you got to get a plus and minus value. That's what this property is saying. Okay? Yeah.
If you graphed it, would the x-intercepts be negative 7 and 7?
That's correct. Yeah, and so they're all related. If we just graph x squared minus 49 straight up, it'd be a parabola opening up, because a is positive. The x-intercepts would be at negative 7 and 7. If we factored it, set them equal to 0, they'd be 7 and negative 7. And if we take the square root of both sides, it's going to be negative 7 and 7. Yeah, they're all related. It's a good question. All right, in this paragraph, they say, hey, they're not all going to work out nice and pretty for you. Sometimes when you take the square root of a number, there is no square root. You got to do the factor tree. Sometimes you're going to be asked to take the square root of a negative number, complex numbers. Okay, so all this stuff is all related. All right, so again, this is like halfway through. And so what's going to happen here is one of the first few steps of completing the square is to get the trinomial, right, that's this thing over here, set up to be a perfect square trinomial. And a perfect square trinomial means both of the factors are identical. Okay, and then we're going to be able to take the square root because of that. Now, someone in a different period was like, oh, these factors are so much easier than the ones before, which is true because it's designed to be that way. And hopefully you'll see what's going on. But all of these numbers are going to be the same. We're looking for the same thing. And so then if you're looking at this and we're going to factor it, you're saying, okay, right, 1 times 4 is 4. Factors of 4 that add to give you negative 4, they got to be the same two numbers. Right, so what are factors of 4 that add to give you negative 4?
2.
So 2 and 2 are the ones we're looking for. Now, you could say, okay, so sweet. So we got x squared minus 2x plus 4. Right, and then we group them. We take out an x minus 2. We group these. We take out a negative 2. We got an x minus 2. And we get down to x minus 2, x minus 2. And so now we can go straight to there.
Yes, I agree.
Is that okay?
Yep. I think.
All right. So there is a relationship. So this is how math works, right? This is why we did the factoring before, because we can't spend all our time figuring out how to factor now. You kind of need to know it, yeah. Right? If we had to learn every step of math every day, right? We'd never get anywhere.
Oh no, I'm chilling. I got it now.
Good. So there is a shorter way to think about this, but that's a you answer, not a me answer, right? So you can always go through this step because that's all you're doing. But hopefully you start seeing what the pattern is going on, because there is a relationship between this number and this number, and a relationship between this number and this number, and a relationship between this number and this number. So hopefully you see that as we do a couple more problems. But you don't have to see it at all. You can always just do this. All right, so now we're at this step. The quantity of x minus 2 squared equals 25. This is exactly the same as if it was x squared equals 25. You treat it the same way. So we're just going to take the square root of both sides. When you take the square root of something squared, they're like inverses, so they cancel. You're just left with x minus 2. You see they got the plus and minus square root of 25, which is necessary. Of course, the square root of 25 is 5. So we have x minus 2 equals plus or minus 5. That's accounting for both of our solutions that we're looking for. We're going to add 2 to the other side. And so now we have this statement right here. So are we okay with that? We see where all that goes? Now you need to simplify as far as you can. So this is coming up with 2 separate equations. One of them is 2 plus 5. The other one is 2 minus 5. Do we see where those come from? Right? The plus and minus here. So then one of our solutions, right, the 2 plus 5, that's 7. The 2 minus 5, that's negative 3. And so then we're saying our solutions are -3 and 7. And just like any other equation, we can go back to the very top, right? And we can plug in, right, -3 in for x. This left side will end up being 25. We can plug in 7 for x, and it'll give us 25. So it's an easy check. Yep.
Does the solution set always have to be in like ascending order?
For me, no. But like for the computer or something, yeah, probably. Yeah. I would just do it that way. There's really no, I guess, because we read left to right, I guess. So, yeah. All right, so let's do the check. We'll do this together, but you guys got to tell me what to do here. So we got this statement. So it's already set up, right? The left-hand side is the only thing we're paying attention to right now. And so now we're going to factor this. So steps of factoring. Is it in descending order? Yep. Is there a greatest common factor?
Probably.
Maybe.
Well, is there or is there not?
Yes.
Yes.
What is it? No. But don't just make stuff up.
38.
1. Yeah, other than 1, there is nothing, right? So you usually don't take out 1 on this step. Okay, so now this is where you guys got to be able to factor. Tomorrow, I'm going to show you a much more shortcut than this. But right now, we got to factor this. So then, right, A is 1, B is -38, C is 361. So 1 times 361 is 361. Factors of 361 that add to give you -38. Now again, don't go through all of them, because we need the ones that are exactly the same. So hopefully there's where you see some of the pattern. So factors of 361 that add to give you -38, but they got to be the exact same numbers. So it's -19 and -19, right? And they're negative because it's -38. Okay, so then, again, what we would do is we would rewrite this. We'd say, I'll do it down here, right? X squared minus 19x minus 19x plus 361. Right, we group each of them. What comes out of the first group?
X.
Okay, x and then x minus 19. What comes out of the next group?
-19.
Oops. What's that become?
X minus 19 squared.
So I'm going to write it out, but like he said, so it'd be x minus 19, x minus 19, but like he said, it's going to be x minus 19 squared. Square root both sides, right? Those are doing it to both sides.
Which cancels the squaring.
Yeah, the square rooting and the squaring get canceled, okay? Everything left over though. Make sure you get, I'm going to write it out, make sure you get the plus and the minus square root of 576. But there is a square root of 576. 24.
Add 19 to the other side.
That's a legitimate answer, but we want to simplify it as much as we can. So then we're going to say that it's x equals 19 plus 24. So that would be 43. And x equals 19 minus 24. Is that okay?
Yeah.
So the next two examples are done exactly the same. It's just about the simplification that makes it any different. Okay? So to save us a little bit of time, right, I won't work it all out, but right, what they did first is say, okay, I need to factor x squared plus 24x plus 144. So it's factors of 144 that add to give you 24, and they're always going to be the same for completing the square. And so then they said it was right in between all this, they said it was x plus 12 and x plus 12. And so is it okay that we're at x plus 12 squared? Or can you accept that that's what it would factor into? Okay, and you can always go through the steps. We're going to take the square root of both sides. Notice that they got the plus or minus square root of 192. Very important to get both of them. So then how do we go from the step that I got the arrow on to x plus 12 equaling plus or minus 8 radical 3? How do we do that?
192 isn't a square.
It's not a perfect square. Yeah, there's no square root of it. So then how can we simplify it?
Would it be a complex number?
We're not taking the square root of a negative, so not yet.
Oh, yeah. Never mind.
That'll come here in a second. But how do we decide? How do we get that simplified? Did you say factor tree? Yeah, factor tree. So let's do the factor tree. What goes into 192?
1 and 192.
Something that's helpful.
24 and 8.
24 and 8. What goes into 24?
8 and 3.
So he said 8 and 3. I'm just going to go there because so I mean you can go all the way down, but if you see a group, then you can stop, right? So then how does that get us to where we need to go? Like how does that work? Now we got 2 8s, right? So they come together as this 8, right? The 3 has no friend, has to stay inside. Poor guy, yeah.
It's got no one to play with.
No one to play with. Feel bad for him. So then we're going to subtract 12 from the other side. So, right, a lot of things going on that you guys got to remember. I mean, that's what they call that math. Right, a lot of steps. So then they get down to here. And I want you to notice something about this. Right, there's our two answers. One is negative 12 plus 8 radical 3. The other one is negative 12 minus 8 radical 3. What do you notice about the difference between these two statements?
Sine string.
Kind of.
Second string.
What is this? What is this one? What does this mean right here? Yeah, approximately. So this is an exact answer, right? Straight line equal signs. These little squigglies means approximately, because these are irrational numbers. Okay, like for instance, pi is equal to pi, but 3.14 is just an approximation. Same kind of thing. So if you type this into your calculator, right, negative 12 plus 8 radical 3, right, that must be 1.86. Negative 12 minus 8 radical 3, your calculator will probably tell you that it's negative 25.86.
So do you want the exact solution, or do you want us like to round?
Usually the way you determine it is like you always get the exact solution, and then if you need to graph it, then you do it there. But watch out for what the directions are asking for. Okay. All right. Again, same steps. We're just going to get a different simplification for our answer. There's one little new thing that you can do. So right there it is. Is the left-hand side in descending order?
Yes.
Is there a greatest common factor?
Yes.
Yes. So before, when we were just doing all that factoring, we just had a polynomial. We had no equation going on. And so you would factor out the 2, and then you had to carry it along because you have to write true statements. Equations give you a little bit more room to play because as long as you, like the two main equation rules are you can add or subtract any number you want, as long as you add and subtract it to each side. You can multiply and divide by any number you want as long as you do it to every term. So instead of factoring out this 2 and having to carry it along, we're just going to say, well, I'm just going to divide everything by 2. So now they go through and they factor this side, right? We factor this. Factors of 529 that add to give you negative 46. They got to be the same. That's the whole point. So two identical numbers. Negative 23 and negative 23. Rewrite it if you need to. But again, there's some relationship between this number and this number. There's some relationship between this number and this number. Okay? If you see it, super awesome, use it. Tomorrow I'm going to show you how to generate these on your own and you won't even have to worry about it. Okay? But if you don't see it, right, go through and find them, rewrite it and do it. Okay? Some people know more about their factors and things. So what? Right? You can do it if you want to do it. Right, so then we take the square root of both sides. Again, we got a plus and minus square root of negative 36. Now, how do we deal with this now? You have factor tree, but we got to do something before we do that, though. Because we got something that...
It's negative.
So then that means we have to do what first?
Complex number.
So then that negative inside the square root becomes a what?
I.
So, okay, yeah, so then it becomes, right, plus or minus I square root of 36. Check out a factor tree if you want, but the square root of 36 is 6. So then we got plus or minus 6i. Add 23 to the other side. There's our two solutions, 23 plus 6i and 23 minus 6i. So that's all you're doing today. So yes, these factor very easily, especially if you can pick up on the pattern. Should we do one or two of your homework problems? It's up to you. I don't care. I don't need to do them. Pick one. Pick one. 1 to 18. Don't forget about the spiral review. 179.
When's that due?
Friday. Friday.
Got it.
So should we do one of the ones from 1 to 18?
We didn't start on number 1.
Let's do number 1. What is it?
No, do 8.
I'll do 8. I'll do 1 and 8, and then I'll be done. What's number 1 say?
X2 minus 18x plus 81x plus 81 equals 49. So Casey.
All right, you guys tell me. What's the first?
You got a
Greatest common factor.
Factor 81.
Okay, so there's no greatest common factor. Factors of 81 that add to give you negative 18.
9.
Negative 9. So can I go right to here? Is this okay with everyone?
Yeah.
Again, there is a relationship between 18 and 9. And there is a relationship between, what?
No.
Why'd that happen?
Right when we got on.
All right, here we go. All right, so again, there is a relationship there. Please, hopefully you see it. If you don't, you'll just have to keep factoring. Okay, so now we can do x minus 9 squared.
Square rooted.
Square root it, so then tell me what it is.
Square root of 49 is 7.
Oh, you're so close. Thank you, plus or minus, plus or minus. So x minus 9 equals plus or minus 7.
And 9.
Add 9 to both sides. 9, x equals 9 plus or minus 7, but we want to simplify that.
So 9 plus 7 is 60.
9 plus 7 is 16.
4.
Shut up. 2.
And 9 minus 7 is 2. Is that right? You wanted 8?
Yeah, why not? Yeah. What's so important about 8?
What's 8?
25x squared
That's confusing.
plus 40x
Well, like 16.
plus 16 equals 28. I don't care.
All right. You tell me.
Oh, why do we do
Picked it.
I said the lottery. Shut up.
I don't see a greatest common factor.
I don't see one either.
So then you have to factor.
What the heck is going on?
So yeah, 25 times 16, if you don't see the pattern, right? 25 times 16 factors of that number that are the same, that add to give you 40.
Doesn't work.
Huh?
It doesn't work.
Yeah, oh yeah, that won't work, yeah.
Wait, so what are we doing right now?
We got to factor 25x squared plus 40x plus 16. Yeah, it works because these are all made to work, okay? Tomorrow we'll force it to work. Okay, but right now they're all designed to make you, make it.
No solution was an answer.
I missed when 1 was the most the answer.
Okay,
Casey?
do multiplication and stuff.
All right, what 25 times 16, what is it?
25 times 16?
400, factors of 400 that add to give you 40.
20.
20 and 20, right? So then, right again, so you probably don't see this pattern because A is not 1. So then we better write it out because these are, you got to be able to solve it. So then we write it out like this.
I need a piece of paper.
I know.
What comes out of that?
5x,
What's left over?
5x, and 4.
What comes out of the next group?
4,
What's left over?
5x plus 4. 5x plus 4 squared.
4 squared equals the square root of 3.
Okay, so what are you going to take a square root now, right?
So then you square root.
28 does not have a square root,
So then you got,
but make sure you get plus or minus the square root of 28.
then you gotta factor it. Would be,
2 and 14.
214.
and then there's a
7 2.
Okay, so then,
2 radical 7.
so 2 radical 7, good.
Yep.
So plus or minus 2 radical 7.
and then that would be,
Yeah, and so then you got to decide when you want to do this. Like maybe you want to separate them first on this one. So maybe you want to do this. Because we got to separate them sometime. So, but we can do this all at the same time at this point. So we're going to subtract 4. So we're going to have 5x equals negative 4 plus 2 radical 7. And then 5x equals negative 4 minus 2 radical 7. When you divide, everything needs divided by 5.
And those are your answers?
Those would be your answers, yeah.
Simplified form.
Yeah, I mean, they could ask you to like do it like negative 4 over 5 minus 2 radical 7 over 5, but I don't know why they would do it. So like those are
Right.
that's complicated.
Yeah.
Is that all right?
Yeah.